And welcome to the second of our two videos. For this one, we're going to be talking about discrete versus continuous graphs. I could go into definitions of discrete continuous, but I think it's actually just also easy to show you some examples. We talk about discrete graphs. We're talking about graphs that are just pretty much broken up into different parts that aren't connected, like this. Here's some dots. These would be considered discrete because, of course, they're not touching. And it doesn't have to be just dots. It could be something that looks like this. Notice we have a bunch of lines, and once again, they are not touching. So that's some discrete. The ones that you're probably more comfortable with, ones you've seen before, are continuous. That might look like this, or even just like a straight line, the linear functions. You guys are probably far more used to continuous. So discrete is just when they aren't touching. We have different parts, and continuous is everything is just one continuous graph. If it ever breaks and there's two different parts, it is considered discrete. So with that in mind, we're going to go over a couple of examples where situations are graphed by, one is graphed by a discrete situation and one is graphed by a continuous. So if you go to page 107, you can see that an example that is discrete. Because take a look at this. This is when students are taking a test. There are 10 problems on the test, and for each problem the student answers correctly, the student receives 10 points. In this situation, it seems like there's nothing in between, no partial credit. So notice how 0 points gives us, zero numbers right gives us 0. But then if you get 1 right, it immediately jumps to 10. There's no in between. There's nothing that's connected. And that's why 2 gives us 20, 3 gives us 30, 4 gives us 40, so on and so forth. So it's important for us to understand that this would be a situation where it would be discrete because there's no in-betweens. Now, if I wanted to figure out what range and domain were, if you don't know what those are the x and y's right here. The x values, I could list them out, right? I start at 0, and then 1, and then 2, and then 3, 4, 5, 6, 7, 8, 9, 10. Not because the number's down here, but because the points are 0, 1, 2, 3, 4, 5, and so on. Meanwhile, the matching y values, the range, going from least to greatest, would be 0, 10, 20, 30, 40, 50, 60. Notice that on the graph, yeah, 55 would exist right around here, right? Because we don't have a point there, because we don't have something touching it, we would not consider that a number that's within the range. And we talk about domain and range, it's a lot easier to do with discrete, but when we do something with continuous, it gets a little bit more difficult. So here's a whole big situation where it's a situation being graphed over time, very similar to what we were talking about in the previous video. And I'm going to show you guys how you would actually graph this. So this is, you can probably tell it's going to be continuous, but we'll see how this goes. We're talking about a bathtub being filled with water. So if we're filling up a bathtub with water, where are we going to start, guys? Where would we put a starting point? Well, if you don't have any water, right, then you just we start at 0, 0. But look at this. After 10 minutes, there are 75 quarts of water in the tub. So after 10 minutes, I'm just going to move to 10 right here. It would go all the way up to 75. So from 0, 0 to 1075. There's a huge change right here. Then it says someone accidentally pulls the drain plug while the water is still running. So obviously the water is going to go down, right? The tub begins to empty. So the tub loses 15 quarts in 5 minutes. So if I put a dot right here, and I move 5 over because it's 5 minutes, I'm going to lose 15. So notice how, by the way, look at the y-axis, it's going 15, 30, 45, 60, 75. So I'm going to go 15 down to 60. Look at that. So in 5 minutes, it went down to here. And then someone plugs the drain and the tub fills for 6 more minutes, gaining another 45 quarts of water. So at this mark right here, I can move about 6 over right here. I'm estimating where that 6 is. And I know it's going to go up 45 more. So 60 plus 45 is 105, right all the way over here. So I'm just slowly still graphing this situation. After a 15-minute bath, the person gets out and pulls the drain plug. So if I jump 15 minutes ahead, guys, does anything happen in between here? Nothing happens, right? Because for 15 minutes of bathing, then they pull the plug. So at this point, that's when they pull the plug. So I'm going to keep a dot right here, a point, And then look at the next part. It says it takes 11 minutes for the tub to drain. So at this point, I should go forward by 15 and go all the way down. Now, the question is, in between these dots, unlike our previous situation, is there something happening in between each? I would say yes. I would connect every single point because that represents the water at those points. And boom, voila, my graph is done. So keep in mind what I did. This was a big situation. A lot of stuff was happening. But the way I handled it was that I put a point down when something changed, and then I ended up connecting the dots. So in this case, this would be a continuous graph. Now, talking about the domain is a little bit trickier here. Remember, domain is the x values, or in this case, the t. Notice how it would include everything from 0 to 46. There's no holes at all in this graph. So I can actually represent this as an inequality, where t, oh, it's 47? My bad. Math is hard. 47. From 0 to 47. See that? T is right in between those two. Let's talk about the range. Range is up and down. It's the y value, or in this case, they give us a q. So think about it. The lowest point is obviously 0, right? But what's the highest point? Yeah, the highest point's at 105, where the tub got full. So q is between 0 and 105. And we're going to practice just figuring out this kind of stuff during class, being able to graph this stuff. But domain and range is something that we should keep in mind. We're not going to go too much into details, but definitely do not forget about this. All right, make sure you guys do your homework, and you have a good day.